On Tomorrow's World Today, we explore the cutting-edge advances that are shaping 4 different worlds. The world of inspiration, where the wonders of the natural world amaze and inspire us. The world of creation, where ideas come to life from traditional arts. The world of innovation, where ideas and inventions move us all forward. The world of production, where innovations are mass-produced to improve our lives. From Inventionland World Headquarters, here's your host, George Davison.
Hi everyone, I'm George Davison. Do you ever wonder how we actually get what we get to make things? Believe it or not, there are really only 2 choices. You either grow it or you mine it. Look around the kitchen in your house, whether it's your countertop or the paint on the wall or even the glass in your oven. It all has to come from somewhere. In fact, almost everything that we depend on is made using materials extracted from the earth. But once they're mined, they have to be processed in order for us to use them. I've sent Greg to a huge tunnel in Arkansas. He's in the world of production, where we're going to explore how things like this started off as rocks.
Silicon dioxide, or as it's commonly known, silica, is present in 95% of the Earth's crust. It is the second most abundant material by weight on Earth, and I am currently surrounded by it. I'm at the Guyon plant in Arkansas, where tons of silica is extracted every day, and it ends up in more products than you could possibly think of. It's in glass, ceramics, countertops, even water filtration systems. But before it can end up there, it's got to start out here. And this is sandstone. And this is nepheline cyanide. Now, these 2 minerals could not be more different. They're mined differently, they're processed differently. Let's explore the world of silica, then find out all about nepheline cyanide. Hey, Danny.
Morning.
Hey, so we're looking at a whole bunch of sand here, but I know it doesn't start out this way. Take me through the process.
Well, it starts out as sandstone.
Well, what happens next?
Next comes blasting.
Let's go see that. So Danny, we made it to the blast site. Pretty excited to see what goes on here. Tell me what's happening.
So to get things started, the blasters are taking these cones out of each hole. The cones are there to protect the hole from collapsing, from water or other rocks from getting in and compromising the hole.
Okay, so about how deep are each of these holes?
Each hole here is roughly 40 feet deep. It ranges from 30 to 50 depending on where we're blasting at the time.
Okay, well, what would help you determine whether you were going to drill down into the mountain and blast this way or drill into the mountain?
So that depends primarily on your mining method and the cost and available equipment at the time. Here, it made more sense to remove the top of the mountainside and be able to access the sand this way, and hence we're drilling vertically. The other method that we do here is underground, and at that time, it was better to simply face the mountain and drill sideways.
Gotcha. All right, well, it looks like these guys are about ready to get things going, so we should probably get out of here.
Yeah, we should.
So Danny, I mean, right before this explosion, we were basically standing out there and everything from this cone on back just got blown off of this wall.
That's right. It's the beauty of explosives.
Wow.
What you're looking at is about 20,000 tons of rock.
And now it's going to get loaded into these trucks and then taken off to the crusher. We're going to crush some rocks?
That's right. That's exactly where we're going next.
Let's go do it.
Let's go.
So Danny, we got to see the trucks loaded up with those big rocks from the explosion, and then we just saw one come and drop that load into the hopper. Now, this looks to be sort of a multi-stage operation here. Can you tell me what's happening?
Yeah, so this is our crushing line where there's 3 separate crushers, a jaw crusher and 2 impactors. And the jaw crusher will take some of the bigger rock that's about 2 feet in diameter or so, and it's gonna break that rock down to about the size of a softball. From there, the first impactor will take the sandstone and break it down to the size of about a golf ball.
Okay.
And from there, the third impactor will then finish breaking the sand down all the way.
And the end product is really that sand, those grains. It's not the stages along the way.
Exactly. We don't want dust. We just want to break it down to the grains. And you're right, the customers, they just want the sand because, as you said earlier, it's used in a variety of ways, such as making glass, shingles, it's used in equestrian arenas, and it's even used as play sand.
Wow, so there's just about any place you go, you're likely to find a sandstone or silicon product.
That's right. You'll come across it in your day-to-day life.
All right, well, Danny, this has been great. I mean, you've taken me through the whole process with sandstone, but now I want to find out about nepheline cyanide.
That sounds great.
I'm at the nepheline cyanide mine in Peterborough, Canada, to get a deeper explanation of what nepheline cyanide is and what it can be used for. Hey, you must be Alex.
Hey, Greg.
How are you?
Good, nice to meet you.
Nice to meet you.
Welcome to Covia's nepheline cyanide operation.
Well, this is really great, so thank you for having me. Tell me more about nepheline cyanide.
So nepheline cyanide's a hard rock. It's very similar to granite. It's also extremely useful, mainly due to its high purity and bright white color.
Okay, so now I've seen your mining operation in Arkansas at Guyon and how they do both underground mining, they also do quarry mining like this, but it looks as though all you guys do is pit mining. So is this all blasted out? Tell me about how we get these layers and how that all works.
Yeah, so this is a large open pit mining operation, and it's a hard rock. So we get the rock from the ground using drilling and blasting. So that helps create these benches in the mine. What you're looking at right now is a loader taking the rock that it's already been drilled and blasted and going to move that to a haul truck.
Well, how long have you been mining here and how long do you think you'll mine here into the future?
Yeah, great question. So we've been mining at this site since the 1930s. So that's a very long time. We also have a long future of reserves ahead of us.
Great, and I know that you guys have a real eye towards the future as far as sustainability goes, and we'll talk about that a little bit later, but what's going to happen with this rock now?
So what you're seeing is rock that's already been drilled and blasted. Now we're using hydraulic loaders to take that material up to our processing plant. That's the first step of the process to make the rock from large, big rocks into small, fine rocks.
I would really like to see how that happens.
That's great, Greg. Let's go see it.
I'll follow you.
Okay.
Well, Alex, I'm familiar with the crushing operation from what I learned in your Arkansas facility, but silica and nepheline cyanide are very, very different materials, so I'm sure your crushing operation has to be different.
Yeah, you're right, Greg. So nepheline is very hard. It's almost as hard as a steel nail. So it all starts with crushing, taking large rocks, making them into very small rocks. Very, very small rocks.
Okay, so what's the next step after they become very, very small rocks?
So once it's the size of sugar or sand, we run it over a magnet. So that helps remove iron from the process.
Is there another step to the process after that iron extraction?
After we remove the iron, we either sell it as sand or we continue to process it further into a finer flour type product.
Can I get a look at that finished product?
Sounds great. Let's go. So, Greg, this is basically how it looks when it comes out of the ground.
Okay, so this is the start of the whole thing. I would like to see some of the products that are the end result.
Great. So I have some small bags, big bags, some different grades of sand.
So this is a big bag of your product ready to go off to where?
Well, we ship this product all over the world.
And now as we look here, I see we have different grades of nepheline in these bins. Tell me what I'm looking at here.
Yeah, so we've got some coarser grain sand, and then we move into some of our finer products.
Okay, what would the sand be used for?
So our sand's primarily used in the glass industry. It helps our customers lower the melting point and also adds hardness to the glass.
Okay, so I would imagine lowering the melting point, that means they're going to use less fuel, smaller carbon footprint. That fits right in with Covia's sustainability mission.
Exactly.
Okay, now we've gotten down to the really fine stuff here, to the flour. What are some of the products that's used for?
So our fine powders go into ceramics, plastics, and paint.
So plastics, it might even be in the composite decking that I have on my house.
You got it. It adds volume and gives it strength too.
Okay, well tell me a little bit more about the paint.
Chances are if you painted the outside of your home in the last 50 years, you've used some nepheline from this site right here in Canada.
So that's what helps make the paint as hard as a rock on the outside of my house.
You got it. It also reduces volatile organic compounds, which have been proven to be harmful to human health.
All right, well, I'm heading back to Fort Smith because I understand they're doing some really amazing things with silica, so I'm gonna go check that out. But you don't go anywhere because I've got some other stuff I need to talk to you about.
Awesome. Sounds good, Greg.
When it comes to mining, silica and nepheline syenite are two materials that we use to make almost everything. Now that we've seen the mining process, it's time to explore the finer details of processing the mined material. I'm at the Fort Smith processing plant in Arkansas to do just that. So KT, I've seen now how silica and nepheline syenite are brought out of the ground, at the beginnings of the process, how they end up in so many different products. But this is a very specific process that you folks do here with the silica sand. Can you tell me about that?
Now, absolutely. Here at the Fort Smith facility, we bring in the silica in the rail cars and basically run it through our thermal process.
Can you show me how that happens?
Absolutely. Lead the way.
All right, KT, so we saw the silica being offloaded from the rail cars and onto those conveyor belts. Does it come right in here from that conveyor belt system?
Absolutely, Greg. So right above us here is our storage tank, our silo that feeds the shank tech weight that actually sends all the material up the bucket elevator. And that's where we start entering the kiln from here.
Okay, but this regulates how fast that all happens?
Yes, sir. This controls how much weight we feed the kiln.
Okay, great. Well, let's go take a look at the kiln.
Let's go. Follow me.
So KT, this is the control room. This is where the kiln is actually operated from.
Absolutely, Greg. This is where all the magic happens.
Now, it's nice and cool in here, but outside there, it is really hot. What's the kiln running at?
The kiln's currently running at 1,500 degrees Celsius, about 2,700 degrees Fahrenheit.
Wow. So walk me through the process. What happens to the sand once it actually hits this stage?
Well, in the kiln, the sand goes through a number of phase changes. The first being it goes from alpha quartz, transitions into beta quartz, and then tridymite, and then the final phase before it becomes a liquid or glass is cristobalite.
How do you control that process?
We control it with the temperature.
Okay, but it never reaches the liquid phase.
No, sir.
That would be the end of it.
That will be the end of it.
Okay, what happens to the sand after that point?
After that point, the sand drops down into the cooler at about 1,200 degrees Celsius, and then it exits the cooler at about 100 degrees Celsius.
Okay, and how do you use the product from that point?
From that point, we basically screen off the sand, and it either goes into one of our products, which is Luminex 14, and gets bagged, or we can send it to the ball mill for further processing.
I want to see that bone mill. Let's go check that out.
Let's go, follow me.
So KT, those screens basically act like big sifters.
That is correct.
And they sift the Luminex out, and that's what falls down in that process.
That is correct.
What happens to it after that?
After that's done, we can either take that Luminex and bag it into a super sack and ship it out to the customer, or we can send it back down here through a ball mill that's behind you, and that mill behind you basically pulverizes it using those little ceramic pebbles in there.
Okay, so these are inside that mill, and basically it acts like a big rock tumbler
That
we
is
used
exactly
to polish stones
it.
when we were kids. Okay.
Yes.
All right, and what can that product then be used for?
So the final product comes out as powder, and that goes into engineered stone, and that is to make countertop, tiles, etc.
It is super, super fine.
Ultra fine.
Now, is this bagged up and sent out the same way?
Yeah, this can either be bagged up into a super sack or loaded bulk into a truck back to the customer.
All right, well, I'm going to hang on to these and take these back to Invention Land with me.
Anytime.
KT, thank you very much. Have a great
You're
day,
welcome.
sir.
You have a good time.
Well, Alex, here we are at one of your tailings ponds. Now, I know that most mining operations end in a tailing pond of sorts, and they can contain chemicals from the process, different foreign materials can end up in there. Sustainability is a big part of the Covia mission. What makes your tailings pond different?
Yeah, so the big difference, Greg, is there's no chemicals used in our process. So the same rock we take out of the ground goes back in it at the end.
So there's nothing introduced here that wasn't here before?
Correct.
Now, what about this covering that we're looking at, this vegetation? Did you have a hand in that as well?
So we did. So we want to make sure that the tailings area is well covered for two things. One, to keep dust down, but it also creates a great habitat for local wildlife.
And I know that you have some neighbors right nearby. You're right near cottage country. How do they feel about having Covia right next door?
Yeah, so we do our best to be as quiet as possible so they can enjoy their time at the lake.
And what else has happened as far as the habitat goes? Have you reintroduced any species?
Yeah, so we're really proud of our turtle nesting survey at NSO. Over the past 5 years, we've been able to collect, incubate, and hatch almost 700 turtles back into the local environment.
That's excellent. Well, Alex, thank you very much. I'm going to head back to Pittsburgh. I know that the CEO of Covia is heading to Invention Land to meet up with George, and I just need you to show me out of here.
Awesome, Greg. Let's go.
Hey, Andrew, welcome to Invention Land.
Thanks, George. I brought you a box of rocks.
Oh, jeez. Well, that's quite an entry.
Yeah, it is. These are some of my favorite things.
All right, let's talk about some of your favorite things. What's this one all about?
So this is a sandstone that we mine in Arkansas. It's crushed down into a sand and used in all sorts of applications that you would know and use in everyday life.
Like if I was in a hardware store, where would I see something like that?
You'll find this material in roofing shingles. You'll find it in grouts, in mortars, in the backing of carpet. You'll find it in windows. Really, there's a whole host of different products that we make out of this rock.
Wow, that's pretty impressive. All right, what about this rock? What's this one all about?
Yeah, so this is a really cool rock. This is called nepheline syenite, and we mine this in Canada, and this is ground down into a sand and then ultimately into a powder, which is used as a filler for paints and plastics.
When Greg came back, he brought these goodies with him, and I saw this one.
That's right. So we start with this,
Okay.
and then we crush it down to this size, and then from there we make various types of sands, and then ultimately the sand is put through a mill where we use these ceramic pebbles, and
Okay.
these pebbles then convert the sand into a powder. So we go from this to this.
Interesting.
And this powder provides a very important functional benefit for paints, for example. This powder prevents paints from fading in the sun. It also makes the paint stronger, so that when your kids write on the walls and you scrub the walls,
Yes.
the reason the paint doesn't come off the wall is because of this powder.
Wow, there's a lot of innovation inside all these minerals and rocks.
There's a ton of innovation wrapped around that, in both figuring out the products as well as innovating our own process to make the products.
Well, I'll tell you what, with all of this going on, I was kind of curious because I got these pictures. Just what goes on with these big holes that you're digging? What happens to them afterwards?
Yeah, so one of the most important things we do is when we are done with the mine, or even as we are mining, is we are reclaiming that site as we go. This year marks our 17th year of publishing an annual sustainability story, And what our goal is in our mining operations is to take the areas that we operate in and ultimately return them back to a natural state that is as good or better than how we found it. We'll take those locations and convert them to prairie land, we'll convert them to a park, we'll convert them to a pond that you can go fishing in. So it's our way of making sure that we do right by the local communities in which we serve, and we leave a lasting positive impression.
Oh, that's great. I think I'm going to go fishing. It
Sounds
was
good.
great to see you.
Good to see you, George. Thank you.